Okay, here we go. Let's give a full sketch of this function here, starting with part A, domain. Domain, I'm asking what x's am I allowed to plug in here? And the answer is all of them. Okay, polynomial, there's no restrictions there. So domain is, you could write the real numbers, or you could write it in interval notation. It's up to you. Intercepts. Intercepts, okay, the y-intercept. The y-intercepts. Well, to find them, you set x equal to 0, and you see what you get. So f of 0 is going to be 2 plus 0 minus 0, so 2. So this is the point 0, 2. X-intercepts. X-intercepts, you set y equal to 0 in this equation up here. So it is 0 is equal to 2 plus 3x squared minus x cubed. Is that right? Yes, it is. Okay, so in principle, we would try to solve this, but this one's too hard. You know, I can't think of an easy way to factor that. We don't expect you to do anything too fancy here. You know, you're expected to factor quadratics and other basic factoring out common factors, things like that. This one's too hard, so we're going to leave this one alone and not worry about that. Okay, in general, we're not going to give you something that's too hard. We'll give you something that can be factored. Okay, part C is symmetry. So C is symmetry, which we will skip. If you want to look into this yourself, please do, but actually there won't be any symmetry here. Okay, again, symmetry is rarely useful. Asymptotes. D. Okay, so for vertical asymptotes, VA, vertical asymptotes, what you would do is you would ask yourself, when is my function, here's my function here, when is my function shooting up to infinity or shooting down to infinity? Well, that's not happening here, right? You're not, you know, I'm never going to have a division by 0 here. So no vertical asymptotes. Horizontal asymptotes. Okay, for this, we'll look at two limits. We'll look at the limit as x goes to infinity of f of x, and also the limit as x goes to minus infinity of f of x. Now, here's my function f up here. Now, the dominant term is the cubed. Okay, that's the only one that really matters. So imagine x is humongous. These two guys here are relatively small. Just ignore them. So focus your attention here. As x goes to plus infinity, this rectangle goes to minus infinity. Likewise, when x goes to negative infinity, this rectangle goes to plus infinity, because you have a double negative there. Okay, so these two limits do not give real numbers. So let's say if you had a real number, then that would mean that you have some horizontal line. Your function may be doing something like this, you know. You'd be coming up and then approaching this horizontal line here. But that's not what's happening here. Okay, we don't have a horizontal line that our function is approaching. So there are no horizontal asymptotes here.